Welcome to Developer Server's YouTube channel. On today's episode, we're going to be creating our own NoSQL database in Python. As usual, today's video is based on the article on Developer Server's blog, and I'll leave a link in the description for the blog post, but also how to get the source code. So what is a NoSQL database? Well, very simply, a NoSQL database is a type of database that can handle a variety of data models, unlike traditional relational databases like SQL that use tables with fixed schemas. So what does that mean? That means that the NoSQL database can store documents, can store files, can store a variety of data types that can be quite useful to structure our data. And in this case, we do not need to structure our data because that's one of the characteristics or key features of the NoSQL databases is that it has a flexible data model, so they can store the data in several different formats. It doesn't have a scheme, unlike the traditional SQL databases that has a table and a defined schema. The NoSQL databases do not require a predefined schema. They're easily scalable in terms of horizontal scalability. They can be high performance, that they can handle large volumes of data very quickly, and they have a variety of use cases with real-time analytics, content management, social networks, and IoT applications as some of the examples. With that said, let's now see how we can build our own NoSQL database with Python. As you can see, we have our Python project on PyChart. Our project will consist of three main files. We have the database file, which implements the actual database. We have the main file, which we'll use to test the database or to run some examples on the database. And we have the test database, which we can actually use to test the database and to make sure that our code is working correctly in terms of the database implementation. So let's see how we can structure the database and how is the code for that. So our main and only database file, it's the database.py file. We do our imports. We're going to need JSON because that's how we're going to be storing and loading the database information. We have the OS for some utilities and also UID for unique identifiers. So we're going to be creating a class called the JSON NoSQL database, which is we're going to be using as a simple NoSQL database that's going to be storing information in JSON files, as I mentioned. So the first method that we have is the init method. By default, our file name is going to be called database.json. We're going to try to load the file from the disk. If that exists, then obviously we're going to be opening the file and we're going to associating our store, and our store is our internal database inside the class. We're going to associate this store with a JSON that we're going to be loading from that file. In case a file does not exist, that means we have an empty database, then our store, we're just going to be creating an empty database, and the database is just a collection of keys and values. With our class initialization done, then we're going to be having the methods that perform the CRUD operations. Let's start with the save method. That's going to be used by the different CRUD methods itself. So the save method, it simply opens the file in write mode and dumps the JSON file that is contained in the store. It has a property format with the ident file. So the save function simply saves the JSON file to the disk. Next, we have the function that actually inserts the document into the database. So it's the insert function, which receives a document, and the document can be any kind of structure. In our case, we're going to be storing JSON document, so our document is going to be a JSON. We're going to be creating a unique doc ID by converting to a string UID identifier. We're going to be creating an entry in the store, meaning an entry in our key value store that corresponds to the database. We're going to be creating an entry with the unique doc ID, and we're going to be associating that document to that doc ID. And afterwards, we're going to be saving that JSON file to the disk. And that's how we can perform an insert method. And of course, we're going to be returning the newly created doc ID. So next up, we have the function that updates a document in the database. Obviously, first it needs to receive a doc ID so that we know which document are we going to be updating and the document to which we want to update that record for. So of course, first thing we need to do is check if that document exists. So we're checking if the doc ID exists in our store, which remind you is the database. If it does not exist, then we're going to raise an error, the key error that the document does not exist. if it does exist, we just simply associate again that doc ID in the store to that document, and we save the database again to the disk. Next, we have our get function, which gets a particular document from the database. So it receives a doc ID that is going to be the identifier of the document we want to retrieve. And of course, we are simply going to the store, getting that key value pair, and that key is the doc ID. And we're going to be returning as a default. If we cannot find, then it returns no, none. If the document does not exist, if the document exists, it's going to be returning the JSON corresponding to that doc ID. Next, we have the delete method. The delete method, of course, also receives a doc ID. Similar to the update method, we are checking if that doc ID does exist in the store. If that doc ID exists in the store, then we're simply deleting that key, and deleting that key deletes the document and the associated JSON, and of course saving the file to the database, or saving the database file to the disk. In case the doc ID does not exist, then we're raising the key error with the doc ID does not exist. And finally, we have our query function that receives a particular condition, where first is setting an empty dictionary that contains the results. Then we're iterating for each of the documents with the doc ID and the document in the store, and we're retrieving the items. So the items correspond to the doc ID and to the document. We're checking if that condition is valid for the document, and we'll see later on how we can define a condition. But if that condition is valid for that document, then that document gets added to the results list with that particular doc ID. And we're returning the results after we identified all the documents that belong to that condition. So let's now check our main file and see how we can find some examples against the database and against our code. So obviously, first thing we do is we import the database. From the database file, we import our JSON SQL database class. We create an instance of the class, which we're calling DB here. And then we're going to be, as first example, inserting some documents. So we're going to do the DB insert the function that we defined before. We pass in our data structure, in this case a JSON file. The same thing for the second document. We call the insert with a particular JSON structure. Both the inserts return obviously the doc ID as we saw. So we're storing the first doc ID and the second doc ID. The next example, we can retrieve one of the created documents. In this case, we are going to try to retrieve the doc ID, the doc with the doc ID 1, and we do the dbget, the function that we saw before, and the output is going to be obviously the document that corresponds to the doc ID 1. We can then update one of the documents by calling the db update. We pass the doc ID and we pass our new document structure that we want. In this case, we'll be updating Alice, her age from 30, that was before, to 31. And of course, finally, we can query the documents. We have our results that are going to match to the query. And this is how we define a condition that we saw before. In this case, we're doing a lambda function with the doc. And in that case, we're saying that the condition that we want is that the doc age is greater than 25. So this will go through all the documents as we saw before, check the age key and check the value and see if the value is greater than 25 for all the documents inside our database. And then it's just going to print the results. Keep in mind that in this example here, this identifier might change in your case because it's creating a random UID as the doc ID key. Now that we have seen the code, let's see the code in execution. As you can see, I do not have any database.json file, so it's going to be creating a new database. I'm going to run the main.py. And as you can see, it performs all the operations. And our first output corresponds to the get, when we're getting the doc ID 1. And our second output corresponds to the query, where we're checking all the documents where the age is greater than 25. And you can see Bob does not match that condition, so it is not returned. And we can quickly take a look at the database.json file. And as you can see, our JSON database is simply a collection of keys and values. We have our first key that was created when we inserted the document Alice with the age 31, that in the meantime has been updated, initially inserted with 30. We have our second document with a particular doc ID, and the structure that we pass. So as you can see, the database JSON file is just simply a collection of items with the key and the corresponding value, where the value in this case is a JSON document or any other type of document that we define. In this case, we are storing JSON. Of course, since we are creating a database and the database can store very important data, we need to also make sure that our code, in terms of the database code, that it performs flawless and without errors. And for that, we can create a couple of tests in Python. So we have our test database file. Again, when importing the JSON NoSQL database from the database file, we're defining a function test database, which we'll be calling later on as the main execution of this file. Similar to the main.py, we are instantiating an instance of our database. First test, we're going to be testing the insertion of a document. So we're calling the db insert with a particular data structure that will going to return a doc ID. And the assert, which is a test condition, we're going to verify by doing the get of that doc ID. We're going to be verifying if that matches our expected structure. So this test ensures that our insert that we have performed before matches the expected structure that we want to be inserted. So it's going to be testing if the insert was successful. Similar test for the update. When we do our db update, we pass a particular doc ID, we update the record that is there, the previous one that we inserted, we update the age to 31. And of course, we're expecting as a test result that when we get that doc ID, that structure has been updated from what was before, alice with age 30 to alice age 31, and that test will return true if indeed the update was correct. Next, we can test the deletion. We do db delete with the doc ID. And as a test, we can obviously assert if the get of that doc ID that we just deleted, if it is none. If it was deleted successfully, then obviously the doc ID that we have inserted and updated, and now we have deleted. If it has been deleted successfully, then the assert is going to match the none. Finally, we can test the query. We again insert two new documents because we have deleted previously the only document that we have inserted into the database. So we insert two new ones, Alice with age 30, and we insert also Bob with age 24. We are going to be doing our db query, and again passing a lambda function, the doc, and we're checking if the age is greater than 25. As before, we're expecting that only Alice is going to be returned. So that's what we're going to do with our assert. We're going to be assert that the doc1, it is in the results because we expect Alice to be returned. And we're going to be asserting that doc2, it is not in the results because Bob with age 24 does not match the query. And if that was the case, all tests have passed. If one of the tests fails, then it's going to raise an exception in terms of the test has failed. Let's run the file and see how our tests go. And as you can see, all our tests passed successfully. And that is it. That is all the code that is necessary to implement a very simple NoSQL database in Python. We can expand this database to also implement indexes, transactions, and also more advanced queries like a data range or a time range or a range in general, and with more conditions, which we'll do in our next video. For now, like this video if you like this content, subscribe to the channel if you want to get notified when I have new content out related to Python, to Django, to AI, and to any type of web applications or command line applications. Until the next time, happy coding!